Welcome to the DPI XML workshop. My name is Mona Ilayan, and I'll be presenting this introductory session. Before we begin, let's run through the learning objectives for this session. I would like for everyone to take away the following: an introduction to XML. What is XML? Related technologies, installing developer tools, and what is XML DTD? What are XML document roots, elements, attributes, entities, and namespaces? Okay, so let's begin. What is XML? XML is the extensible markup language. The X comes from extensible, the M stands for markup, and the L for language. Since 1998, XML became a World Wide Web Consortium standard or recommendation. This is important because the W3C proposes and standardizes ways of working with web technologies. It's really important to remember that XML is extensible, and what that means is that XML offers the flexibility to make up your own tags to solve a specific problem in marking up some information if there isn't already an existing tag set. We'll look at examples of that soon. So what is the difference between HTML and XML? So XML has been around and widely used. It's similar to HTML in that it is tag-based. So if you are familiar with HTML, you'll find XML very easy. However, you really don't need to know HTML to learn XML. And while there are a lot of similarities between HTML and XML, they provide different web functionalities. When you render an HTML document in a web browser, you don't see the tags. It's made so that it is human readable. HTML describes how information is presented and formatted on the page. XML, on the other hand, describes the contents of an HTML page, or in other words, it describes web data. XML was created to help reduce deficiencies that were associated with its two predecessors, SGML, Standard Generalized Markup Language, and HTML, which are both markup languages. SGML was considered too difficult for people to use, and HTML was too limited and polluted. XML is a derivative of SGML, and most of it comes from SGML without change. You may have heard of Text Encoding Initiative, TEI, which is also a derivative of SGML, and is another source of technology that contributed to XML. XML has influenced several web technologies and contributed to the foundation of a number of them. For example, XHTML. It extends the HTML language. It is formatted as XML syntax and has specific rules about format. It uses the tag-based structure and follows the restrictions in XML. So it tried to get rid of the loose HTML rules. RSS. Many of you have probably heard of it. It enables publishers to syndicate data automatically. And this also uses an XML file standard that ensures the publications are compatible with a variety of machines or programs and technologies. KML, or Keyhole Markup Language. A lot of you working with geographical tools may have heard of it. It is an XML notation for geographic visualization. This list is not expansive. I'm just giving you a few examples that you may have heard of. There are many more technologies that are extensions of XML. When working with XML, there are technologies out there that make it easier to solve problems related to XML effectively and efficiently. I've offered a list here of a few that you may or may not have heard of. XQuery. This is an XML query language that provides a way to search, extract, and modify XML documents. It's used with relational databases. It's also used to construct new XML documents, especially when an element and attribute are known. XSLT, Extensible Style Sheet Language Transformations, make it possible to transform XML documents into other XML documents or other formats such as PDF or HTML. XML is a text-based file, and you can use any text editing software available to you. If you already have one available on your computer platform, feel free to use that. The reason why you might want to download a text editor is because it might be faster and easier to edit your code. It depends on your text editor. But certain text editors make it visually possible to identify tags, elements, attributes simply through color coding. Here's a list of a few free text editors. The free ones for Windows are Notepad++, YNote Classic, For Mac, there's Text Wrangler, there's EditX, and there's also Notepad++. Here's a list of commercial ones. There's Oxygen, there's Sublime Text, and there's Dreamweaver. As with anything, XML also has advantages and drawbacks. Some advantages of XML are: XML code can easily be read by humans and machines. XML is written in plain text. It offers the flexibility to create tags that work with your information without having to rely on the restrictions proprietary standards provide. It makes it possible for industries to create tags that are relevant to their information without having to use generic tags. You can separate your XML content from the way your data is presented. If you have ever used or created your own WordPress site, for example, there's an option to download a copy of your content in XML. It is platform independent and can be used with a wide variety of tools and web technologies. Some of the disadvantages of XML are that the syntax can be at times repetitive and too lengthy, and this may reduce the efficiency of other applications. XML doesn't support data types, so it does not provide specific integer or image or string or Boolean definitions. Data types help identify what a specific object can be and how it can be manipulated and what operations can be performed. If you don't plan your tags and elements ahead of time, you might run into problems later on. The flexibility in creating a data structure is a blessing and a curse. If you have a lot of information in one file, your XML can get harder to read. RSS feeds are a good way to view XML examples. If you visit CBC RSS feeds or the Toronto Star, and I've provided the links here, you will see an example of an XML file. And when you click on one of these stories in the Toronto Star, you'll see that they're using XML to offer descriptive words for their content. For example, they're using a channel, title, last build date, pub date, copyright, and so on. And all of these are descriptions that detail what is being placed between the tags. With XML, you can structure your data and provide accurate descriptions of your content. To give you a sense of why describing data is so important, let's take this example here. Mary, Rebecca, Adams, Mark, Davids, December 4th, 1990. You may be looking at these names and thinking, what is this and why are these names listed and what is the significance of this date? If we had the XML tags around here, you'll find out that this is a personal record for one person and their personal information. It lists their first name, middle name, and their last name. Then it lists their partner or spouse's name, their last name, and their date of birth. Without this description, you wouldn't know what it is. But with XML, we can label this data, and this will help clarify what our information is representing. So now, if I present this information this way, you can see how XML helps identify content by providing descriptions as well as structure to the data. Without these tags, we would not have a clue what all these names are, and it would be confusing to understand their relationship to each other in this specific form. So as demonstrated above, the tags provide clarification and descriptions to what this data is, and XML structures the data so as to identify the context of this data. In this example, we are working with a personal record that is composed of the person's full name, spouse's name, and date of birth. This record can expand to include place of residence, nationality, spoken languages, and so on. But all of this information will be contained within the personal record. Oh, is that you? This record can expand to include place of residence, nationality, spoken languages, and so on. But all this information will be contained within the personal record tags. So in this instance, my root tag is personal record that holds the data for this specific person, Mary. What this example also demonstrates is the flexibility of XML. The tags created above may not apply to a specific XML standard, but tags I've chosen to create to solve my data problem. Since XML is extensible, I am given the flexibility to create my own data structure. If there was a pre-existing XML standard, I could choose to use that instead of building my own data structure, which requires a lot of thought and consideration. If it isn't well thought out, it could get messy very quickly. XML code is very similar to HTML in that it has tags, and these tags are used to 1. Wrap around specific words, phrases, and structural elements. Wrapping a tag around a word or phrase, etc., allows the user to provide detailed information about the text. We'll look at that more closely. The other thing is that tags are nested. Part of creating an informational structure, tags are placed within root tags that provide a general top-down description. Each nested tag provides additional details. XML can be thought of as a tree structure with a root, branches, and leaves. In an XML document, you will notice that the first line offers a declaration statement that states the version and type of encoding used. The next line is the root element, and within the root element are the child elements. Let's take another example. Let's use the Princess Bride book. You'll notice that every element there has an open and close tag. The closing tag is identified by the / before the tag name. Previously, I showed you what a simple XML file looks like. I happened to mention things like tags, elements, and attributes. Now let's delve a little deeper into understanding all of these terms and how they are used in an XML file. There are a number of XML content types that you will come across while working with XML. These include the document declaration, elements, attributes, comments, character data, and entity references. Let's begin with the document declaration. I've showed you in one of the previous slides what that statement looks like, and here it is again. You'll notice that the declaration statement looks different than the rest of the XML code. It has a question mark after the opening bracket and a question mark before the closing bracket. In between, again, as mentioned, the XML version, the encoding used. There's also an optional standalone declaration. In the W3C, XML declarations are recommended. The declaration statement identifies the file as XML with a specific type of encoding. The statement also appears on the first line of the XML with no spaces before it. The standalone attribute distinguishes if the file is independent or dependent on another. The standalone attribute is set to no if it is dependent, and yes if it is independent. XML elements are also known as tags, and these are valid names that provide description for the data. A valid element name can begin with a letter or an underscore. Then they can be followed by more letters, numbers, hyphens, periods, and underscores. You cannot use the XML string because W3C reserved it. Tag or elements are case sensitive, so make sure you open and close a tag, paying close attention to the way it's been written. Otherwise, your information will not be parsed correctly. Invalid name tags are shown in the examples below. The first example provides a name tag that starts with a symbol, the second one with a number, and the third one with the XML reserved name. On the other side, you see the valid names, and these are the ones that start with an underscore or with a letter. Attributes provide additional information about the element or tag. They only appear in the opening tags after the tag name, and they are unique to each tag. The same attribute name cannot be used on more than one tag. They follow the same rules as tag names. They can only start with a letter or an underscore, followed by more letters, digits, hyphens, periods, and other underscores. You cannot use XML to begin an attribute name because these names have been reserved. So the example below provides an XML attribute. Type is equal to JPEG. Comments are annotations to your XML code, and they're used to make it easier to understand and explain your XML element for others to follow. Comments are not inserted for machine readability, but for human use. Here's an example of what a comment would look like. They are defined with an opening angle bracket followed by an exclamation point and 2 dashes, and it ends with 2 dashes and a closing angle bracket. They can be placed anywhere because all they're doing is providing the person who is reading the file with information on how to use XML. They appear independently, not within element brackets or before the declaration statement. Character data is declared by this line. two angle brackets, opening and closing. Within the angle brackets, the first thing is an exclamation mark, an opening square bracket followed by the words "see data," another opening square bracket. Here you would enter your content, then a closing square bracket to enclose the content, then another closing square bracket to indicate the end of the see data. Character data are similar to comments because the XML parser ignores information provided within. This allows you to enter any type of special characters that normally would not be valid in XML. Sometimes it's used to enclose Boolean statements or functions. Here's an example of one see data tag. Entities represent a symbolic representation of information. It helps in situations where you might be using redundant information or when you know you'll be changing some information often and when you're using special characters. You define an entity using the following declaration. And there are two types of entities. There's a character entity, and these are used to identify special characters that are otherwise invalid or don't appear on your keyboard. For example, if you use this entity, 033, this entity defines the exclamation mark. However, when you're using it in XML, you need to first place an ampersand, then a hashtag, then the entity. So altogether it would look like this. When parsed, it would show an exclamation mark. The second type of entity is the general entity. These are easy ways to define a string of content and to use a term to identify it. For example, my entity declared here is author with Charles Dickens. If I want to identify Charles Dickens anywhere in the text, I would just place an ampersand and the word author. When you're referring to a specific entity, you first type the ampersand and then the entity name followed by a semicolon. XML syntax rules. If you are familiar with HTML, you'll soon find out that XML syntax has more stringent rules than HTML. So just to give you an idea of an XML coding rules, I've listed the most basic here. XML must have a single root tag. This is required. In my personal record example, the root tag was called personal record. XML must be well formed. This means that in an XML document, you must have a root tag element, which we just talked about. Each element must have a closing tag. The tags are case sensitive. The attribute values must be placed in quotes. In HTML, sometimes you can get away with that. The use of nesting in elements must be done properly, which means that you need to make sure you close a nested tag before you close the root tag or the parent tag. Validating XML documents. These rules are really important, especially since XML provides the flexibility to create your own tags. Therefore, you need to make sure your code is valid and well formed. So normally, XML documents are parsed using an XML parser. The parser validates the code by checking if the code follows XML's rules for a well-formed XML file. What you can do is you can also create a document that outlines the rules you followed in creating your XML file. In addition to the XML file, you can also provide the parser with another file to inform the parser of the set of rules you've used to create your customized XML file. These rules can state when a specific element can be used, what values an attribute can take, for example. So when the parser will read the rules and compare them against the XML file. If the XML file passes, then all the rules, including being a well-formed XML file, have been implemented. The document containing the rules is called either a document type definition, DTD, or an XML schema, and we'll talk about these in further detail a little later. XML namespaces. What are they? Well, namespaces are used as a way to prevent element name conflict. So one thing that will always come up is the fact that XML is designed to be extendable, to provide the flexibility for the developer to create customized tags or elements. So if, for example, an XML file is at some point combined with another file, element conflicts will arise. A very popular example is when an XML file also contains HTML code. In HTML, we have the table tag. In XML, we can define our own elements. So say we also want to use a table element, but as part of a description of items in a furniture store. So our XML file will have something that looks like this. So now when the HTML parser runs through the code, it'll be confused to find unfamiliar elements such as the name of the table, the width of the table, and the length. So to avoid this problem, we use namespaces. They're declared using this form. And here's another example of another form that we can use to declare namespaces. You can either declare namespaces in root elements or in the element where they will be used. So here's my example of how namespaces appear so as to avoid confusion for the parser. We briefly talked about DTDs. Basically, DTDs are documents that you run through your parser along with your XML file. They contain a set of rules about the XML elements, attributes, entities, comments, etc. The parser compares XML document against the DTD to ensure the file is well formed. Document type definitions are simple and not very powerful. They are written using syntax that is a little different from XML. Usually, DTDs are a standard agreed upon by a group of people so as to interchange data, and it helps other people read and understand your code if they have an understanding of the DTD. DTDs also constrain XML document content to ensure that the XML file is well formed. This includes specifying what kind of content a tag can contain and where it should or shouldn't appear. You can either choose to include the DTD as a separate file, or it can be declared within the XML document. They're easy to create, but aren't very powerful, as I said before, in comparison with the XML schema. And we'll talk about XML schema soon. First, I want to give you a quick overview of how to declare DTDs and DTD elements. Here's an example of what a DTD declaration looks like. In a DTD, elements are declared with the following syntax. There are different types of DTD elements. There's an any content element, and this has no constraints. It can have text or other elements. It could be anything. Here's an example of how you would declare this element. Another example of element types is element content. This contains specific child elements that are declared in the DTD. And this example over here with the text can either have novel, play, or short story as its elements. It is called a choice model, and only one of these elements or tags can appear within this element. Another example is the novel element. Here, this element can have the author, title, pub date as its elements, and these elements should appear in that order. First the author, then the title, then the pub date. The next type of element is a mixed element, and these elements are elements that contain other elements and character data, or scripts. And here's the syntax to declare it. Finally, there's the empty content element, and this one has no child elements like the image tag in HTML. And I've provided an example of how it's declared as well. You can also specify how many elements can appear by adding one of the following symbols. The question mark means that you can add 0 or more of the elements. The plus sign means that you can add 1 or more of the elements. The asterisk means that you can add 0 or more of the element. And here's an example. XML Schema is a more powerful, sophisticated, and flexible alternative to DTDs. They are written using XML syntax rules. In DTDs, you have no way of specifying how many times an element can appear in another element. You can't even constrain the value of an element to a specific pattern. So what schemas do is that they define elements and attributes that can appear in a document, elements that can have child elements, the number of child elements, and the order in which they can appear, empty elements and ones that include text, data types for elements and attributes, default and fixed values for elements and attributes. Unlike DTDs, schema is always stored in a separate file. You don't have the option to store them in the XML file as with DTDs. So while schemas are powerful, they are harder and lengthier to write, but they offer a finer level of control to ensure XML files follow the rules and are well formed. The XML schema language is called XML Schema Definition, XSD, and they usually have a file extension of .xsd. Schema has a number of features, and it would be time-consuming and complicated to get into every feature available. So for our introductory session, we'll look at how to define some schema elements so you can leave with a general understanding of them. Like DTDs, schema elements can either be empty, mixed, or element content. When you declare a schema element, you can use the schema element tag followed by the name of the element and the specific type. The element type can either be simple or complex, and these types can also either be built-in, already defined, or you can define your own custom types. An example of some of the common element types are string, decimal, integer, boolean, date, and time. So I could create this XML schema element for author with a string type of string. And schemas also allow you to indicate the min and max times these elements can appear. By default, the min and max values are set to 1, and these specific attributes are optional. So for example, if I want to create a genre element, I would declare it like this. What that means is that we want at least one genre, but as our maximum, we have an unlimited number of genre tags that we could add. And XML Schema allows us to set these values. If I knew I was going to only be adding 5 genres, then I can set my maximum occurrence to equal 5. With XML schemas and DTDs, you can also declare attributes and set restrictions. There are a number of online resources that will help you learn more about XML, its schemas, and DTDs. I've provided some links here for you to reference if you are interested. This was sponsored by the University of Toronto Scarborough and its library, Ryerson University, Brock University, and this research was supported by the Social Science and Humanities Research Council of Canada. A special thanks goes to Ryerson for hosting Day 3 of the conference, Center for Digital Humanities, Ryerson University Library and Archives, the Director of E-Learning, the Learning and Teaching Office, the Office of the Dean, Faculty of Arts, the Department of English and its MA Literatures of Modernity program, and the Master of Digital Media program for donations of financial support. The Dean of Faculty of Humanities, Brock University, for a contribution of financial support towards the conference, as well as contributing to planning. Victoria Owen, Chief Librarian at the University of Toronto Scarborough, for her generous financial support and staff resources. Shirk Connections grant, without which none of the wonderful research and discussions generated here would be possible.